Hello all, my name is Vasanth. I am a OSF's or DevOps batch student. Now what I'm going to do is I'm going to deploy two instances and one S3 bucket, and inside one S3 bucket we are going to upload some object like files or something text files. So this everything we are not going to do in the AWS console. We are going to do with the help of Terraform, Visual Studio Code and Git. So I'm going to install Git, Terraform, and Visual Studio Code in the AWS virtual machine because I don't have any virtual machines or a server. So I'm going to get a virtual machine from AWS console, and by on the way I'm going to install these three tools. Let us open the AWS console. I'm going to sign in the AWS console. Select EC2. EC2 is called as Elastic Instance, Elastic Compute Cloud. I'm giving name as test VM1 for server. It's a demo server. Now for demo server, take Windows image, Microsoft Server 2019 base. It will be much faster than 2025. I'm selecting T3 micro only. Now keeper and select AWS fuel keeper and select executive group. This I almost allowed every port in this security group. Now this is only the configuration. Now I'm going to launch the instance. This is a previous launched instance. So now I'm going to terminate this. Now currently running only one VM, that is test VM1 for the demo server. I'm going to install a Git, Terraform, and Visual Studio Code by using the run command on the AWS console with the help of installation script generated by Gemini AI tool. Because it takes time to install the Git, Terraform, and Visual Studio Code one by one manually. So I'm going to use the script which deploys or install the Git, Terraform, and Visual Studio Code within a less time taken in virtual machine. So I'll go to Gemini AI, where I have already generated a script by using some prompt. So this is the prompt. I'm going to copy this prompt. Once the virtual machine is once the virtual machine is deployed, I will paste in the run command script, or else we can paste now also. Actually, the script uses chocolately a package manager for Windows because it is the most reliable way to handle unattended installations of software like VS Code, Terraform, without needing to manually handle EMSI URLs or GUI graphical user interface wizards. So with the Terraform, we are going to we are going to deploy two instances and one is three bucket and inside one data object or a file anything we are going to with a single click. Now I'm from my system manager. We will get the run command option. So in run command section, we will be available to paste the script. So this is a searching method. So document name prefix equals AWS run PowerShell. Run PowerShell script. If you give this search, you will get uh, this interface. So when we get this interface, I'll paste the script here. Now we can install the Git Terraform and Visual Studio Code within 5 minutes. I'm going to choose the target as the instance VM. I'm going to disable this S3 bucket or else it will be associated with these tools. So I'm going to disable that one and I'm going to run this command. So you can see the command ID also. It was sent successfully. By the way, I will get the code for Microsoft Edge browser because in 2019 server, Microsoft Edge browser will be not available because I want to check a Terraform registry and all in Microsoft Edge browser. So instead of creating manually, I'm going to install the Microsoft Edge with the help of script automatically. So it will get me a browser automatically. Once the script uh, finishes, after that I will paste the script. Now I'll check our instance is deployed successfully. Yes, the three out of three checks has been passed. That means the virtual machines are running perfect. So there is no issues. In system manager, I have already pasted the run command. Let us check what is the status of that. So the command is in progress. So terraform is an declarative tool. You tell the terraform that you want final outcome to look like. For example, I need two virtual machines and a S3 bucket or something like a load balancer. The terraform figures out the steps to make it happen. So it is also called a cloud agnostic tool. It uses a single consistent workflow to manage the infrastructure across the dozens of different providers, including major clouds like AWS, Azure, and GCP as well. And also it works on on-premises systems like VMware also. So this I'm going to use the Visual Studio Code workspace to create a new folders for our project and open it is in Visual Studio Code. It will be uh, user friendly, and we are going to integrate with Git so that we can use it very easily. It will be very comfortable. Uh, these are the blocks, the same what we are seeing in picture. The same blocks we will be copied from the Terraform registry. From that registry, various commands will be there, various scripts will be there. We are going to copy from the Terraform registry and going to paste here. So these are the blocks. The blocks will be contain arguments, the parameters, everything. So while by editing these arguments and all, we can configure the instances, the resources that we want to deploy in the AWS console. So successfully, the command has been worked. Now I'm going to run another command for Microsoft Edge browser. While searching for the tool, we have to give the correct uh, spellings. If spellings are wrong, you won't get that interface. So now we got that interface, PowerShell script interface. Now you can see we are just installing the Microsoft Edge on the server. I'm choosing the target as our VM server. I'm going to run this script. You can see the command ID was successfully sent. The script which I have generated from Gemini AI tool, I have shared it in the GitHub repository. We can generate a various scripts like this in Gemini AI for Azure, GCP, AWS console, everything. I'll show you the repository. So you can see the URL. That is the URL. If you search the URL in your browser, you will get this bootstrap script. So you can copy, paste. You can see the our previous video also. Previous video we have done for Azure. The same concept also we are applying here for AWS. In Azure also we done a run command script to install the Git, terraform and Visual Studio Code. But for AWS and Azure there will be different script. You cannot use that Azure script for AWS and AWS script for Azure because it confuses it. So our script is successfully uh, worked, so successfully run. So I'm going to take a RDP connection. I have decrypted the password. Now I'm going to paste this password on for RDP password. Now it will be get connected. Yes. You can see the Visual Studio Code has been installed successfully. Even Microsoft Edge browser also installed. I just changed the theme. I'm going to install the extension for Terraform so that it automates the command. It will be very user friendly to use it. This is the Microsoft Terraform extension. I have installed two extensions, one from HashiCorp Terraform, another from Microsoft Terraform. The next we'll check whether Git Bash is installed or not. So you can see that Git Bash is installed automatically. I'm just changing the font size. Now we'll check whether the Terraform is installed or not. Just Terraform -v command, Terraform version. If Terraform is installed, we will get the version also. So Terraform version 1.14, the latest version has been installed successfully. So everything is installed automatically. I just opened the desktop folder. I'm going to integrate with Git Bash. I think the font is visible to you. Now I take the Git Bash. So Git Bash console interface will be user friendly to use. So currently I'm in desktop directory. Uh, Now I'm going to create a new directory called AWS. Now I'll change You can see the AWS folder has been created in desktop. So I'm going to change the directory AWS. In AWS, I'm going to create a file called deploy.tf. So in deploy.tf, we are going to add the blocks. So this file can be opened in this Visual Studio Code interface. So this is a very powerful editor tool. So here we can copy paste the blocks from the terraform registry, or else we want to create, we can create it here also. So now I'm going to open the terraform registry. Browse providers. So there are various providers. I'm selecting AWS provider. In the AWS provider, I'm going to copy this script from this registry. I'm going to paste here. From documentation, we will get the configuration to authenticate with AWS console. So this is the script, usage script. So I'm going to copy the script and paste it in this file. So to communicate with the AWS console, first we have to verify the region, which region already the AWS console is present. It is a Europe North 1. Now access key. To communicate with the AWS, we want the access key. For that access key, we are uh, going to get it from this AWS console. This is the IAM rule, Identity Access Management. From here, we are going to create a new user. I'm going to give name as a Terraform new user app application. I'm attaching policies as the administrator access. Administrative access will be get all benefits of AWS console. Actually, there is an error called a user was not created because the name which I given has some spaces and all, so it should be not present that. So I'll again cancel this and I'm going to rename again. I'm going to create a user again. Create user. So now be careful while giving the name here. I'm going to give name as a app, Terraform app user and attaching the policies directly to the administrator access. You can see that Terraform app has been created successfully. So when I go inside this Terraform app, there is the option called create access key. When I click that, various options there. In that we are selecting application running on AWS Compute Service. And next, it is asking description tag values. I am giving it as a Terraform application. That's enough. Now it will get a key for us. So this is the access key. I'm going to copy this access key and paste it here. After that, we want a secret key. For secret key, we have we there is a secret access key copied. So I'm copy that. I'm going to paste here. So both we got access key and a secret key. So this is enough to communicate with the AWS. But whereas in Azure, we want tenant ID, subscription ID, client ID, then again client secret is it's very secret confidential to communicate with Azure, but it's very easy to communicate with AWS here. So next we have to the next step we have to install the EC2. We have to deploy EC2. For deploying EC2 Elastic Complete Code, Complete Cloud. There are various scripts. I'm going to select this one, AWS instance. I'm going to copy this. So it is under EC2 Elastic Compute Load. Here you can check and get it from here. I'm going to paste here. This is AMI image ID. So I'm going to remove this and I will get the AMI image ID from console and I will paste here. Sorry, actually I have to give this name to that block. So this is the terra deploys a block of the name. If you go to the EC2 instance, we will get the AMI catalog. So AMI means the image Amazon machine image. So there will be various types of images. So randomly I select one image and I'm going to paste this image ID to the block of that resource. So I'm paste here. So tags name, this is the name of the instance. So I give name as terraform VM1. And now when the same block when going to copy and paste here, so I will get two instances. I copied and pasted here. So just we have to rename the tags and all. I'm going to rename this as 2 and this tag name as terraform VM2. So above block is terraform VM1. This is terraform VM2. If I copy and paste again here, I will get again one more instance. So like that we'll get multiple instance. So this is the method how we are going to get the multiple to deploy multiple instances. So now I am searching for a AWS S3 bucket. So we are going to deploy S3 bucket now. So I'm going to copy paste this. I copied and now I'm going to paste here in this file. So I'm going to edit this one. DevOps bucket. Please make sure that the name the name which you give for the bucket should be unique one. If it is not unique, then it won't get deployed. So I'm giving a unique name. Our bucket AWS Dev 303. The tags name and the environment let it be same. Now I'm searching for the code that we have to upload a blob, any file, blobs or object, anything. So I'm searching for the S3 object. I copied this S3 object to upload files. So I don't want this command. Only the above arguments is enough. I remove that one. I'm going to rename this as file. Now I'm going to create a file bucket. So this is the name of the bucket which we have previously created. The unique name, our bucket AWS Dev 303. Now key, I'm going to give the key. Key is nothing but the name of the file. This is the key is the display file. I'm giving as a vasanth.txt for source. Dot refers to the current directory slash vasanth.txt. So now this terminal got stuck. I cannot. I'm going to close this terminal and open again because it got stuck. I'm not able to enter the values, so I'm going to close this terminal. Now I'm going to reopen again. Now I'm going to create a new file called vasanth.txt inside the AWS. So I'm going to edit here in AWS. The file has been created. Vasanth. Here I'm going to give a name as hello all. Just some text inside the file. Some message I have. Now I'm going to initialize the terraform in it. Terraform is an infrastructure as code. This is called the IaaS tool built by HashiCorp. So this is the infrastructure as code which we have given in this file, which we have, which has some blocks. So that blocks are the infrastructure as a code. So this terraform, when we initialize this terraform, the terraform finds for these blocks in the backend and verifies it whether we can communicate with AWS or not. Everything runs in the background. So instead of manually clicking through cloud portals like AWS console or Azure portal or Google Cloud, uh, we can build our servers, networks, and databases and write configuration files in this Terraform only. So you can tell to the Terraform that how the final outcome should do look like. The Terraform figures out the steps to make it happen. So this is how the Terraform turns manual cloud infrastructure management into automated repeatable code. So Terraform has been successfully initialized. Now we are going to validate. So it validate the parameters what we have given. The configuration is valid. Next we have to check the plan, Terraform plan. In Terraform plan, it shows uh, the plan which we have given to deploy on AWS console. So it will show that 4 to add, 0 to change, and 0 to destroy. And we have given Terraform apply. When we give Terraform apply, it going to deploy the two instances, one S3 bucket, and going to upload this text file. Everything at once. It automates the process. You can see that the AWS instance Terra deploy one creating. Uh, the file which we are going to upload, it is an object, so we have to change the file into the object. Now it will going to work fine. Just we have to change this. Now I'll just save this. Again, I retry by giving the command terraform apply. You can see it is successfully uploaded. The file also is uploaded. S3 bucket also created. 2 instances also created. You can see the Terraform VM1 and the VM2 which we have given in the Terraform file that has been created. The 2 instances created successfully. Now we have to check for S3 bucket. S3 bucket also created successfully, and inside there is an object called Vasanth.txt which we have given. You can open the file. When we open the file, you can see hello all which we have given that one. There the same file. So this is how we deployed. We can deploy multiple instances, multiple S3 buckets, multiple uploading the files. Only if you want to remove the resources which we have deployed, just we have to give the command terraform terraform destroy. When we give this terraform destroy, it will completely uh, it completely removes everything what we have deployed in the AWS console. So it will get be all removed. Yes. So this terraform handles the complexity of creating the nested resources in the correct order. The process involves creating a set of configuration files and then running the standard Terraform workflow. So this is the process for deploying an EC2 instances in AWS console. So Terraform often uh, performed within the Visual Studio Code. We'll check whether it is removed or not here in the AWS console. We can check the Terraform VM1 and VM2 has been terminated. There is only one running VM. The VM which we have deployed has been terminated. Now we'll check the S3 bucket. There is no bucket inside. It has been deleted. So we have automatically deployed the instances and we have automatically deleted the instances. So thank you for watching the video. We'll see you next time. Thank you. Bye.